Okay, last class what we have seen? Last class. Okay, last class what we have seen? Last class we have started the concepts of transistor biasing. Okay, what is the need for biasing transistor? Why are we going to perform biasing in transistor? Okay, already we know that a transistor will operate in three regions. Okay, one is active, cutoff, saturation. We have to fix the transistor in active region. Okay, because active region is the most efficient region of the transistor. So we have to fix the active region as the operating region of transistor. Okay, for fixing the active region as operating region, we have to provide two biases. One is emitter based junction, another one is collector based junction. We will give forward either or reverse bias. So biasing is first most important thing is we have to fix the transistor should operate in active region. For that we have to apply a two biasing. So for performing biasing we need to bias, that is the first most important. Second one, we are going to perform transistor means the transistor should produce output which greater than input signal. The main application of transistor is amplification. Okay, we are going to boost the low level signal into high level signal. So that is the two reasons for why we are going for biasing. Okay, in biasing is classified into four types. First one is emitter bias, second one is collector based bias, third one modified collector based bias, fourth one voltage divider. These are the four different biasing circuits. Okay, we can use any one among the four, depends upon the user application. Okay, first last class we have seen the operation of emitter based bias. What is the advantage of emitter based bias? What is the advantage? It is the most simple. Okay, it's very easy to construct. Okay, that is the first most advantage. Second advantage is we can fix Q point at any time. Okay, one more thing is Q point is very important. By fixing the Q point only we can get the output 100%. Okay, the output characteristics will be, we know that, and the Q point will be fixed at nearly midpoint of the graph. Okay, suppose when we fix the Q point above the midpoint means what will happen? Upper portion of the output signal will be clipped, removed. Okay, so we cannot fix the Q point at upper portion of the graph. Same, when we fix the Q point at lower portion of the graph means automatically the graph of the output negative cycle will be clipped. So we won't get any 100% output. So in order to get 100% output, we have to fix the Q point at midpoint. Okay, already we know that. Okay, graph is like that means we will draw one load line. We cannot fix here. We cannot fix. We have to fix at center point. And when we fix the Q point at center point only, we can get the 100% output. That is the Q point. Okay. So emitter based junction second advantage is we can fix Q point at any point. Okay, we can vary easily. That is the advantages of emitter based bias. What is the drawback of emitter based bias? It is highly dependent on temperature. Okay, we cannot maintain thermally equally to entire region. Okay, entire sessions, because they for every second temperature will either increase or decrease. Okay, so automatically whenever temperature is increasing or decreasing, beta value will be changed. So it will change the Q point. Whenever beta changing means Q point won't fix at center. It will move either towards upward or towards downward. So in emitter based junction we cannot fix the Q point constantly. Okay, it will vary. It's highly dependent on temperature. Okay, that is the advantage and drawbacks of emitter based bias circuits. Next we move to collector based bias. Okay, in emitter based bias the beta value will be in the numerator. Okay, numerator means automatically beta is highly affected by temperature. So we move to collector based bias. Okay, in collector based bias beta term will become in the denominator. Okay, when we compare both the biasing circuits, beta is very less dependent on temperature and character based bias. Okay வா, emitter baseல என்ன ஆச்சு, beta ஓட வேல்யூ நம்ம derive பண்ண ஈக்குவேஷன்ஸ்ல எல்லாமே எங்க இருக்கும்னா beta ஓட வேல்யூ it comes in numerator. Numerator means it is highly dependent on temperature. Okay, in character based junction it will come in the denominator. Denominator means it is inversely proportional. Okay, so we can withstand the temperature level in the character based bias. Okay வா, last class வரைக்கும் பார்த்தோமா. Okay, next one derive பண்ணியாச்சு. Okay, what is the equation for VCE, character based bias circuit? VCE, VCC minus IC plus IB into RC. Okay, next one, advantages. Okay, first one, advantages. First point, it is a simple circuit. Advantages, it is simple circuit. Second point, if the temperature increases, collector current also increases. If temperature increases, collector current also increases. If VCE decreases, IB also decreases. IC depends on IB. Okay, next one, disadvantages. First point, stabilization is very poor. Disadvantages, first point, stabilization is very poor. The second point, in this circuit, we are giving voltage feedback. In this circuit, we are giving voltage feedback which reduces the gain of the amplifier. Which reduces the gain of the amplifier. Okay, again same draw advantages. First point is it is simple. Okay, we can't use more than many components. We will use only transistor and some resistors. Okay, it is very easy to construct. Second one is IC equal to beta into IB. So IC is highly related to IB. Whenever beta value increases, IC values will also increases. So we can easily control the collector current. Drawback is stabilization is very poor. Stabilization means nothing but the process of shifting Q point from one point to another point. We have to fix the Q point for constantly for entire session. Okay va? Q point number fix பண்றோம்னா என்ன பண்ணும்? And the Q point should be fixed at the point for entire region. Okay va? The Q point should not move away from that point. But in character based bias, stabilization is very poor. Due to that, the Q point will shift towards either upwards or downwards. Okay, that is the first drawback of character based bias. Second drawback is, what is it? Okay, we will provide a feedback. already I told that gain is nothing but output voltage divided by input voltage. Okay, due to we providing Sai Rajendran. Sir கூப்பிட்டா எங்க சார் அங்கேயா பேரண்ட்ஸ் வந்திருக்காங்களா? பட்டன்லாம் போட்டு okay, listen. In character based bias we will provide a feedback. Feedback is nothing but I'm connecting the output to the again into input, that is the feedback. In character based circuit, bias circuit, due to feedback the gain will be get reduced. Gain is nothing but output voltage by input voltage. For example, I'm going to consider gain value as 5. Okay, output voltage I'm going to provide input voltage as 2 volt. What is the answer of output voltage? Gain value is 5. I'm going to provide 2 voltage input. What is output voltage? 10. Okay. But in character based bias circuit, due to feedback, the gain will get reduced. So automatically, when gain is reduced means output voltage will also reduces, which affects the amplification. Amplification should always high, but in this case due to feedback gain gets reduced. Gain gets reduced means automatically output will be reduced. That is the drawback of character based bias circuits. Okay, next we will move to the third, modified character based bias circuit. Base bias circuit. Again same, draw the same diagram, but in emitter you draw one resistor. Okay, listen. In normal character based bias circuit will be like this. We will directly connect the emitter to the ground. Okay, in order to rectify the drawbacks of character based bias, I am introducing one resistor at the emitter. Okay, just draw one emitter resistor in the emitter junction. Okay, same procedure. What we did in the character based bias circuit, we have to find the two KVL equation in the two branches. Okay, find the equations. Same IB VCE. Okay, first thing what we have to do, apply. We have to divide the circuit into two portions. One is base, another one is collector. First apply KVL at the base circuit. Same what we have did in collector based bias circuit, we have to do the same operation in modified circuit. Okay, what are the three parameters we have to calculate? IC, IB, VC. These are the three parameters we going to find. First, apply KVL at the base circuit, which means this branch. Okay, so I can write Okay, first one, VCC is the entering. So VCC minus IC plus IB RC plus voltage across this resistor is IB, sorry, minus IB RB minus VBE minus, but in the last circuit we won't add this component, okay, because it is grounded, so we won't add this, but now resistor is present, so we have to find the voltage across the RE. Voltage across RE is nothing but IE into RE, so minus IE RE equal to 0. Next step, substitute IC equal to beta into IB in this equation. Okay, so we can get IB. Find the IB. IB should be VCC minus VBE divided by RB plus beta into RC plus RE.
சார் ஐஆர்இ தானே சார், அப்போ இங்கேயும் அந்த சப்ஸ்டியூட் பண்ணணும். அந்த டைம் அப்படியே இருக்கும்.
ஆமாம், பரவாயில்ல, இது இப்படியே இருக்கட்டும். நோ IB equal to VCC minus VBE minus IERE divided by beta plus 1 RC plus RB. Correct? Correct. Minus RC plus. Correct? Okay, next one. Apply KVL at the collector circuit. Collector circuit, same. VCC minus RC IC plus minus VCE minus IE are equal to 0. From this, you find the value of VCE. It's easy. இது போகும்போது பூரா okay, finished? Okay, next type is last type, voltage divider bias circuit. Okay, finished. Okay, take down the voltage divider bias. Voltage divider bias. The resistor R1, R2, and RE. The resistor R1, R2, and RE, providing the necessary biasing, providing necessary biasing to the circuit. R1 and R2 acts as voltage divider. R1 and R2 acts as voltage divider due to temperature dependent the collector current IC increases. Due to temperature dependent the collector current IC increases, the emitter current also increases. That will affect the base current. It reduces the base current. Which will compensate the changes in IC. Which will compensate the changes in IC. Okay, listen. This is the fourth type of biasing circuits. Okay, we already know that each biasing circuit will have some advantages as well as drawbacks. Okay, when we see the other three types, stability is very poor. So all the three were highly dependent on temperature. Okay, in order to rectify the temperature dependent drawback, we are going to provide a two extra resistor. Okay, that is R1 and R2. Okay, before we won't use two resistance for voltage divider for emitter based or collector based bias circuit, but here we will use R1 R2. R1 and R2 will consider as voltage divider. Okay, it will provide a one voltage, that is VB. Okay, this VB will compensate the changes in beta. Okay, so it won't changes the beta in respect to temperature. By using the correct value of R1 and R2, we can change the compensation of beta. Okay, இதுக்கு முன்னாடி நம்ம பண்ண முடியாது. Okay, because we will use only RC, otherwise one resistor. Okay, but here we will use R1 and R2. This R1 and R2 will control the VB. So VB will compensate the value of beta. By raising the value of R1 and R2, we can change the beta, as well as reducing the value of R1 and R2, we change beta, reduce the value of beta. So we can change the value of beta by using these R1 and R2. So this is the most advantageous circuits of among the remaining three circuits. So in practically for amplifier, we will use only voltage divided bias circuit, because it will provide a high stability. Okay, due to base voltage, we can change the stability point. Okay, so it will provide constant Q point at the active region. So there is no point of changing from either upwards or downwards. So it is the most advantage circuit among the three circuits. ஓகேவா, நம்ம ப்ராக்டிக்கலாக நம்ம யூஸ் பண்ணுறது எல்லாமே இந்த சர்க்யூட் தான். ஓகேவா, நீங்கள் இதுக்கப்புறம் பார்த்தீங்கன்னா தெரியும், இப்படி தான் இருக்கும் சர்க்யூட். இதுக்கு முன்னாடி பார்த்த சர்க்யூட்லாம் நம்ம யூஸ் பண்ண மாட்டோம். பயாசிங் இதுதான் யூஸ் பண்ணுவாங்க. ஏன்னா இது மூலயமா நம்ம ஸ்டெபிலிட்டி ஈஸியாக அட்டன் பண்ணிடலாம். ஓகேவா, இந்த ரிமைனிங்ல என்ன ட்ராபேக்னா ஸ்டெபிலிட்டி தான் ட்ராபேக். Q பாயிண்ட் நம்ம ஃபிக்ஸ் பண்ணோம்னா அது மாறிட்டே இருக்கும். எதனாலனா டெம்பரேச்சர்னால. ஓகேவா, இங்கே வந்து டெம்பரேச்சர்னால மாற பீட்டாவை நான் என்ன எது மூலமாக கண்ட்ரோல் பண்ணுறேன்னா VB மூலியமாக கண்ட்ரோல் பண்ணுறேன். ஸோ we can fix that issue. Okay, that is the advantage of voltage divider bias. So first we have to find the value of IE. So for finding the value of IE, we have to consider this circuit. Okay, this lower up. Okay, same we have to apply Kirchhoff voltage law. Okay, when we apply Kirchhoff voltage law, what will happen? From here to here. Okay, what is the name for this node? VB. So VB is the starting entering. So VB should be considered as positive. The remaining all the values should be negative. So VB minus this is VB. So minus VB minus this current flowing to the RE. The voltage across RE is nothing but IE RE equal to 0. Clear? I am going to apply KVL for this branch alone, this base to this emitter. Okay, here VB minus VBE minus IERE. Okay, so I am applied KVL. We have to find the value for IE. So IERE equal to VB minus VBE. So I need only IE. So IE equal to VB minus VBE divided by this is the first one. So IE Okay, I'm going to modify the circuit as this simplified circuit. Okay, listen. Now I'm going to I modify the circuit into this circuit. Okay, finish that. Okay, okay, listen. What is the connection of these two resistors? Already. What is these two connections of resistors? Series or parallel? It is parallel. Okay, I'm going to find the total resistance of R1 and R2. I'm going to change the total resistance as RB. Okay, just I'm simplify this circuit into very simple circuit. Okay, RB. So RB is nothing but R1 is parallel to R2. What is the total resistance of parallel circuits? Actually 1 by R1 plus 1 by R2. When we cross multiply, we'll get that R1 R2 divided by R1 plus R2. This is RB. Okay. Next one, VTH. I'm going to consider this VB as input voltage. Gavani, I'm going to consider this VB as VTH. So we have to find the voltage at this point. Okay, for that finding the voltage at this point, we have to apply voltage divider rule. What is this voltage divider rule? படிச்சிருக்கீங்களா? So I'm going to find this voltage at this point. So corresponding resistor is R2. Okay, what is the voltage, input voltage? VCC. So R2 into VCC divided by total resistance. Total resistance is nothing but R1 plus R2. Clear? I am just applying voltage divider rule. Voltage divider rule is nothing but I am going to find the voltage at this point. Okay, so corresponding resistance is R2. So input voltage is VCC. So VCC into R2 divided by total resistance is R1 plus R2. So I am writing VTH equal to this. Okay, next apply KVL at the input side. Okay, now we are going to apply the KVL at this input side. Okay, what is the first voltage value? VTH. Just I am going to apply KVL at this branch. So VTH is the input voltage. So we will start from VTH. VTH minus here IB. So IB RB minus VBE minus IE RE equal to 0. Clear? Okay, next we have to find the value for, substitute this value in this. Okay, listen, wait. Okay, this is the transistor. How the conduction will take place in transistor? How the conduction will take place in transistor? NPN or PNP? First, electrons or volts will move towards the base, from base to collector. From this operation, we can conclude that IE equal to IB plus IC. கரெக்டா? நம்மளுக்கு ஸ்டார்டிங்ல என்ன இருக்கோ அதுதான் பாதி பேஸ்க்கும் போது ரிமைனிங் அங்கேயும் போகுது. கரெக்டாக இருக்கும். அப்போ ஐ இஸ் நத்திங் பட் addition of base current and collector current. So we can write IE equal to IB plus IC. So IE இங்க இருக்கு. Substitute IB plus IC. Okay வா? From this equation you can derive IB. Okay, find the value for IB. கிடைச்சது கிடைக்காம இருந்தா தெரியுங்க. Okay, listen. Okay, this is the final equations of voltage divided by circuit. Okay, from this we can see that the equations of 1 plus beta. Okay, how we can remove this term 1 plus beta? For example, I'm going to add this value with RB. Okay, when I'm taking RB is very higher, so we can neglect this term. Okay, so RB is nothing but combination of R1 and R2. Okay, by changing the value of and R1 and R2, we can change the value of beta. Okay, this is the difference between this circuit and other three circuits. In other three circuits, we cannot change the value of beta. Okay, but in voltage divided by circuit, by fixing the value of RB is nothing but R1 and R2. Okay, by properly selecting the R1 and R2 value, we can change the beta. So in this circuit, beta won't be changed. So the Q point will be fixed constantly. Stability is very high when compared to other three bias circuits. Okay, so practically we will use only voltage divided bias circuits for practical purposes. Okay, when we fix the Q point in voltage divided bias means Q point will be fixed at this point for entire sessions. It won't shift towards upward or downward. So it is the advantages of voltage divided bias circuit. Clear? Okay, finish the. Okay, listen. Next topic is stability factor. Okay, it is okay. Listen, finished. Okay, next topic is stability factor. We're going to find the stability factor for all the biasing circuits. Okay, first of all, we know what we mean by stability factor. Stability factor is nothing but change in degree of operating point due to temperature. Hey, Gavani, stability factor is a parameter. Uh, is used to measure the change in degree of operating point due to temperature. Okay, நான் already சொல்லிருக்கேன். All the biasing circuits are highly dependent on temperature. So operating point will change according to the temperature. So stability factor is used to measure how much the Q point is changing from normal point to another point due to temperature. That is the stability factor. Okay வா? Temperature நால என்னோட Q point எவ்வளவு மாறுதுன்றத find பண்ற parameter தான் stability factor. So for stability factor, we are going to find the value for all the four biasing circuits: emitter bias, fixed bias, collector based bias, voltage divider bias. Okay, now we will see the basic derivation of stability factor. இது உங்களுக்கு தேவையில்லை, அதனால நான் அப்படியே எழுதி போட்டேன். ஓகே, நமக்கு என்ன வேணும்னா ஃபைனல் ஈக்குவேஷன் இது மட்டும் வேணும். ஓகேவா, இதுதான் ஃபைனல் ஈக்குவேஷன் ஃபார் ஃபைண்டிங் ஸ்டெபிலிட்டி ஃபேக்டர். ஓகேவா, நம்ம எல்லாத்துக்குமே என்ன கண்டுபிடிச்சிருக்கோம்? எல்லா பயாசிங் சர்க்யூட்ஸ்க்குமே ஃபர்ஸ்ட் கண்டுபிடிச்சோம். எமிட்டர் பயாஸ் ஐபி, டிசி மைனஸ் bias. Okay, this is the IB equation for emitter bias. Okay, now we are going to differentiate this IB with respect to IC. What is the value? என்ன value வரும்? Differentiate this IB with respect to IC. என்ன value? S equal to 1 plus beta divided by 1 minus என்ன வரும்? இங்க டேர்ம் IC இருக்கா? இல்ல, அப்ப என்ன ஒரு ஆன்சர் 0. மேக்ஸ் தெரியுமா தெரியாதா? தெரியல. So 1 minus 0. So S equal to 1 plus beta. So for emitter based bias, S equal to 1 plus beta.